move MVS. Move means that the hand move in articulated. This is the trajectory. So this is the hand will be moving in a curve, very beautiful curve. MVS means that the hand move from the current position and to the destination in a straight line. And H open, and as I said, whenever you use H open or H close, you must add this one, okay? Because our industrial robot only have one hand, and H open, space one, or H close, space one, that is to close, open or close the hand. OVRD is used to change the speed, and means that, so this is the last statement, and I want to use to tell the system that this is the end of the program. And delay means that I want to delay for several seconds. Delay space a number, this number unit is seconds. So what I told you guys about delay is that we can use delay to ensure that the industrial robot's hands move to the positions precisely. Right? So this is what I'm going to test you, and in our exam quiz or exam. So HLT, HLT means hot. Can somebody tell me what is this guy's function? HLT. Yeah.
It stops the program so that it doesn't keep on repeating itself over and over.
Yeah. Yeah, great, thank you. So HLT means that if we have put the HLT before the end, then the program will run only once. Without HLT, the program will be running continuously, repetitively. So I want you guys to know what's the function of each of these commands. And then we talk about these commands one by one. So move. The robot moves to the designated position with the joint interpolation. You can see the joint interpolation. It is possible to specify interpolation on form using the type instruction. Appended statement with or with if can be designated. So what does that mean? It means that when I move the hand from this position to any other positions, so I at the same time I can just let some lights on, lights be on. So this is hand. For example, this is a hand, and I want to move the hand and to the P1 position, and then move to the P2 position, and then this is the P1 position, and then we call this is a P2 position. As I said, I want to grab this is a block. However, I should go to a distance which is vertically above this position, and then I go down. From here to here, I can either use move or MVS, and then I open my hand. If my hand is already open, I can just close my hand, and then I can just retract my hand to this position. But here, I can just grab the hand and go here, right? And go here. So this is a tool from this one, which is not vertically, but this is in this axis. So this guy, I can go to the position that is above. This is there a position, and then I can just grab it and retract my hand. So here, here is the trajectory of this hand, and then we are going to talk about this one by one. So here you can see from P2 and to this location, and we want to turn on the signal bit 17. And how can we write this program? And the next slide, I'm going to show you guys. Okay, so this is first. I'm going to tell you and how I will move my hand. So here is the example. So here's the example. Okay, move to P1. So that is move to P1. And second one, move P1 plus P2. So move to the position obtained by ending the P1 and P2 and calling the elements. So this is Cartesian coordinate system. So X, Y, and Z. And second one, third one, P1 multiplied by 2 move to the position relative convert from P1 to P2. So this in the 2 position, right? So this is in the 2 position. And then move on P2 minus P50. And keep in mind, guys. So here, this example, we use MELFA BASIC 4. Okay? The difference, the subtle difference between MELFA BASIC 4 and MELFA BASIC 5 is that for the BASIC 4, we use minus 50 means that is vertically above the desired location. Make sense? Because a lot of customers they just give some feedback to the Mitsubishi company, they want to say minus is going down and positive is going up. That's the reason for MELFA BASIC 5, and we use the positive. You understand, guys? You need to be very, very careful. Okay, if I were you, I would like to write down BASIC 4. I use minus 50, and BASIC 5. I use positive 50 or 50, and to denote that I want to move a location that is vertically above the desired location. All right, so this is a subtle difference. I want to you guys to know. I then move the P to the P2, and then from P2 I move to the P3. Now this time also minus 100. Minus 100 means that this is about 100 millimeter above the desired location, but at the same time I want to turn on the bit 17 and let the light be on when I move. And then move P3, and move to the P3 or P3, and with if this is condition, if this one is true, that means if the bit 20 equals 1, and then I'm going to skip. So that means so if the input signal bit 20 turns on during movement to P3, the movement to P3 is stopped, and the program proceeds to the next line. And then move P3, move to P3, so move P3 negative 100. So this is explanation for the previous slide. Any questions regarding this one? As I said, the best way of learning new language is that we have a functioning example, right? If we take a close look at this is a functioning example, and we can learn a lot of things, the syntax rules. Any questions regarding this one? So what I want you guys to know is that I would suggest you use the capital letters all the time when you program it. So MVS, and you can see the MVS, so you can see very, very clearly. So this guy, and just move the hand in a straight position, in a straight line, and in a straight line, and straight line, and straight line. So be very, very careful, okay? And you can use this is the MVS only if you are sure that between this location and the destination location, there is no any obstacles, no any people or other things, because you don't want to damage it or damage them, right? Do you? I'm kidding. Be very careful. So this is example MVS. So this is very, very similar with MOV, but keep in mind, MVS it is moving in a straight line. MOV is moving in a with a joint interpolation. So that means all this is a 5 joints. They are moving in articulate pattern. So very, very harmonic pattern. So this is very, very beautiful curve, beautiful arc. So I will not talk about this one. So the only difference between this slide and the previous slide is that we change MOV to the MVS. Then kind of open and kind of close. So you can see we can use hand open the space 1, okay? Because we only have one hand, and hand open space 1 means that you open your hand, and hand close 1, you are close your hand. So here is a 2. That means some industrial robots, they might have multiple hands, but for our case, we only have a single hand. Hand one, its index is 1. As you can see, so this is a hand open 163.63.5. So this is I'm telling you this command and starting grasp force, holding grasp force, and starting grab force, holding time. So for this one is more sophisticated. But for our case, we just use hand open, H open 1 and H close 1. So the operation of each hand is set with parameter and type. Okay, you keep in mind, and you are not authorized to do anything. Okay, so you just write the program, test your program. That is what we want you to do. For all these other things, the parameter setting. So this is a tedious the task Frank and I will handle. Understand? Clayton.
Yeah, why is 63 3.5 kilograms?
So the grasp force, how much force you want to apply?
Yeah, but why is it 63? Like
Why?
Yeah, why is 63 equal 3.5? Where is that conversion?
This half means is for holding time. Holding time. So this is for the sophisticated industrial robots, not for our case. So for the highly sophisticated industrial robots, and you can specify the grasp force. How much force? How much is the gradient force? And you can just specify. That's a very good question. The status of hand output signal when the power is turned on is set with parameter. And as I said, you do not need to take care of this. And what you need to do is just use the hand, and don't set this. Don't change this any of these parameters. So here, if something condition is met, and you do something, if this is greater or equal, less than or equal to 1, and go to 120. So if this one equals 0 and go to 120, you can see this is less than or greater means denotes not equal. So this is for the hand open and hand close. And this is delay. Okay, so this is delay and delay time value. This is what I told you guys. And DLY and the space and given number. That is number is a second. So what it says, and when programming the robot, and between each peak and place command, there should be a time delay to allow the robot to properly and grasp the part. And there are problems that can occur if timing of the peak and place operation is done incorrectly. So this includes several things. And so you need to delay, okay? Delay. As long as you have a delay, that means your hand can go to the desired location precisely, and then you can grab it. Otherwise, you just go there, go to the neighborhood of this is a desired location, and then move to next location. So RD, OVRD, and we, as I said, and we use this one and to set the speed. The full speed is 100%, as I said, and so this is the percentage. Okay, so this is the ratio, and we say this is a imagine this. This is a number, and this is a percentage. 50 means 50%. 100 means 100%. 100% means that is a full speed. And I told you if you use the full speed when you run your program, the industrial robot table will be vibrating because the dynamic effect. Well, because quickly speed up, quickly slow down is a dynamic. OVRD. So this OVRD, this is what I want you guys to know, that you just know how to change the speed. And so there's a lot of explanations, but I don't think they are very useful. But you just know, and you can just specify the speed by changing the number behind the OVRD command. The end. The end command is used to mark the end of program. It stops the program from executing other commands stored in the memory. Right? The hot command stops the robber and halts the execution of program. And when program is started, it is executed from the next line. A hot. Hot means that you can just stop there. Questions so far? No question? No question. So there is a program heading. Program heading it is used to improve the readability of your program, right? And the last time I told you, for this is the alpha MELFA BASIC 4 or 5, and we use apostrophe to denote that after this apostrophe, so this is the comment, and comment will not be executed. Do you still remember, guys? So especially if you in this team you have you have several students, several researchers, and each of you guys is working on a separate part, your individual part, and in order to facilitate this communication between you guys, and you need to write these comments, and ideally, and for each of these commands. Okay. So for here, for the program heading, that means I use several. This is the comments here. And program name, you can write the program name. For example, assign one PRT. You can denote here author who write this part, date, when this part is written, version. And so it is which version 1, or you have read several versions. Miscellaneous notes, and you can just write all these things as long as they are meaningful for you and for your team members. And then you can just specify this is Z offset, Z axis 50, so these kind of things. So this is a program. So here from 100 to 170, and these are the comments. Okay, the comments are used to enhance the readability of your program. Any questions regarding this one? No question? No question? We can move on to next one. So now this time, we have learned the basic commands. Now, we want to learn something fancy, right? So today, now we want to learn the circular interpolation. We just learned how to move my hand from one location to another location, and now we want to learn how to move my hand in a circular pattern. Learn continuous movement, CNT. Hi guys, do you know what the CNT is? Clayton, you are smiling and you have another meaning. Yeah. The CNT, because I'm doing the physics. So CNT, in that context, the CNT means carbon nanotubes. You can see the acronym, and in different contexts, the same acronym stands for different things. You understand, guys? CNT. Whenever I see outside this context, CNT for me is a carbon nanotubes, and I use a laser to cut the nanotubes. So here the continuous is continuous, and then we learn the go stop and return. And you can see when you see a go stop and return, and maybe this resonated with you on what you have learned the similar things in the PLC, right? Okay, so that is another language. And we want to learn for next. For next is the loop and how to write a loop. And because in the industry, and we want these industrial robots to do some tedious, repetitive, this is the things for us. That's the reason for next, this is a loop. So this is very, very useful, very, very important statements. And then we use define palette. and palette command. You guys know what is a palette? You guys know what is a palette? Martin, Ricky,
Free wood.
huh?
Use it to, you use them to move large loads around, like a warehouse or a Sam's Club.
Yeah. Okay. So this palette here in this context means that I have a grid. I have a grid. So and suppose, so my in the warehouse, for example, you just say the Sam's, right? For maybe for other the supermarkets, and they have this is the grids, and so this is on these nodes, and they are these nodes, and these nodes stands for either the workpiece or the stuff. So these stuff they are arranged in some pattern. Okay. So we saw palletizing is a pallet. This is a pallet. Palletizing means that I want to move all these the work pieces or these items from this grid, and we call the grid, and to another grid. And another grid might be this looks this way or might be looks different. So I need to define the palette. I need to use the palette to automate the movement from this grid 1 and to grid 2. Okay, so this is called palletizing. You understand, guys? Okay, good. So we will do a lot of fun using the palletizing. Circular interpolation movement. The robot moves along an arc, right? Along an arc, designated with 3 points, and we know that, and we can use 3 independent points to define an arc unit, right? Right? Okay, so using 3-dimensional circular interpolation, and you know the interpolation, right? What's the interpolation, Harry?
We have one point and another point.
Yeah.
In the middle point.
Yes. And this is arc. This arc, we do not hands do not move continuously, but we do the interpolation. Interpolation means that from the points to another point, these are discrete the points, these continuous points. But macroscopically, and when we see this looks like a curve. This is called interpolation. And we use discrete the points and to mimic, to approximate the continuous curve. So this is called interpolation. If the current position is separated from the start point, when starting circular movement, the robot will move to the start point with linear operation and then begin circular interpolation. So this is the understandable. So here are several circular interpolation movement: MVR, MVR2, MVR3, and VC. And so they are different. Okay, so MVR is commonly used one. So for this MVR3, okay, I'm going to show you guys. MVR3, I'll talk about this one very quickly. And we have start point, transition point, and end point. As I said, and if we have 3 independent points in a space, and we can uniquely define a circle. Right, guys? So as a result, so this MVR, you need 3 different points. So MVR2, and we have start point, we have end point, and then we specify a reference point. So I move the robot with a circular interpolation from the start point, end point, without passing the reference point. And it is possible to specify the interpolation from using a type instruction or appended statement, and with or with if can be designated. This is MVR2. MVR3, and you have start point, end point, and center point. Right? So you can see the difference between MVR3 and MVR, right? So the MVR, the 3 points, and all these 3 points are on the arc. But for MVR3, only the first and second points are on the arc, but third point is the center. We know that center is not on the arc, right? You guys agree? So case one means that this is a circle, and case two is this point one and point two. So this is the center. So this is the circle I'm going to approximate. And so this is MVR, and so this is MVR3. MVC, we have start point and end point, transition point one and transition point two, and move the robot with the circular interpolation in order of the start point, transition point, and transition point, end point. So this is MV3, MVC. So here, and so this is to show you guys. So this hand, before I just do the circular interpolation, I move my hand in a straight line from here to here, and then I have start point. This is P1, P2, and P3. So these 3 points uniquely define a circle, and then I just go this way, right? And so they are. This is the 3 points. They are entered in sequence. So here I'm P3, P4, and P5, and also 3 points. But here these reference points here, the reference point MVR, this is the MVR2. So here it is from here to here, 2 points, start point and end point, along with the center point. This is MVR3. So this is a start point and also end point, transition point 1, transition point 2. So here is the MVC. Hayden.
Is there like a mechanical or software reason you would want to move in circles instead of lines, or is it just if you want to achieve moving in a circle, then you would use this function?
Sometimes you need to do some manipulation to move your hand in a circular way. Yeah, for example, sometimes we use the industrial robot to help us to hold the welding machine. Right? Sometimes when we do some welding operations, and the environment is very hazardous, very dangerous for the human. So we want to use the industrial robot to do these kind of things. We use the hand and to securely hold the hand. Let the hand hold this is the welding this tool. And then we suppose we want to weld. So this is 2 pieces in a circular part. And you need to program your industrial robot. That's a very good question. So industrial robots, they are used to help us. And when we need their help. One is that the very tedious task, right? Our human being, our human being every day is emotional. Do you guys agree? If I ask you guys to do the same thing, 1,000 times, maybe 10,000 times, even though it is very simple, but you will be frustrated, right? That's the reason sometimes we need to use industrial robots to do this. Industrial robots will never ever feel frustrated. Trust me. As long as you give the routine maintenance and give proper this is the power, and he can work for us. And this is one thing, very tedious task. A second thing is very dusty, very dangerous environment, and human being should not stay there for a long time. If this is the case, and we can use industrial robots to help us. You understand, guys? Keep in mind, industrial robots are born to help people. Questions? No question? So this is example. Okay? So this is MVR. So actually, this is what I just told you guys. So here is the explanation. 1 means the path. 2, 3, 4, 5, and this is what I just told you guys. The CNT, and CNT continuous movement. So robot continuously move to multiple movement position without stopping at each movement position. And you can see here, okay. If when you write the program, when you implement run your program. Written in the CNT, and you will know how useful the delay command will be. Alright? So the start and the end of the continuous movement are designated with a command statement. Start and stop, and the speed can be changed even during continuous movement. So CNT1. So CNT1 means that this one means and you are enabling this continuous movement function. And CNT0 means that and you are disable this function. You understand, guys? First, you need to enable it, and then you do something, and then you can just disable it. So this is CNT1 120. So this designates the start of the continuous movement, designates that the start point neighborhood distance is 100 and end point is 200. So this 100 with the 200 neighborhood, and the distance neighborhood distance is 100, and the end for the end part of the neighborhood distance is 200. I'm going to show you an example. So here for this one, all right? So this is Robert move continuously for less than the smaller distance or either proximity distance when moving toward P6. So this is a P6 here. So here, from P1, we move the hand from this location to the P1, then the straight line, and then there's from P2 to P3, P4 continuously for less than the smaller distance of either the proximity distance when moving toward P5 is a default value, right? This is the default value. Or the proximity distance to the starting point of the path to P6, and this is 200. So this is 100, and here is a 200. So here this continuous, and this is this one, and this one explains, and for each of this is the segment. Move P1 and CNT1, you enable this is a continuous movement, and then you want to move MVR, you have specified 3 points P2, P3, P4, and P2, P3, P4 using MVR command, and then you move MVS P5 in straight line to the P5, right? To P5, and however, and then you have CNT1 200 and 100. So the sets the continuous movement start point neighborhood to 200 and end point neighborhood distance to 100. So this is the starting and this is ending. So this is default. This is default. Okay, this is default. So this is 100. So MVS P6 to the P6 here, and also you need to have this MVS P1. So this is MVS 1, 200, 100. So this is the 100, right? So here is this is the 200, and so this is 100. So starting and ending. And then after you come back to P1, MVS P1, and you can disable it. So finally, you enter this program. So here you can see the neighborhood. I want to move my hand from P4 to P5, but I have a CNT command, and that's the reason. So I will not go to the P5 precisely. Instead, and I have a curve. So this curve. So this one have 100, and so this is default value 100. Questions? No question? No question? We talk about subroutine. A subroutine is our old friend. We know that. We define subroutine, and then in the main program, and if there's a need, and we can call the subroutine. The command go subroutine and calls the subroutine as a designated line or the designated label. So on a go subroutine, on there's something, there's some number. So if some conditions are met, and we call the subroutine according to the designated variable number, the value conditions, and follow the integer value order. I'm going to show an example. Return returns to the line following the line called with the go sub. For example, on M1, what? You can see on M1 is integer. So it depends on this guy's value. If M1 equals 1 and you go to 100, 100 is the line number, is the label of the subroutine. If M1 equals 2, I go to 200. If M1 equals 3, I go to 300. So these three numbers, 100, 200, and 300, these three numbers, they are the labels of the subroutine. You understand? If some condition is met, I'm going to some subroutine. So here is an example. Okay, so here, and P offset Z dot Z equals 70. That means, so this is offset value equals 75 millimeter. And then go sub 1000. And so here is 1000. So this is 1000. And 1000, and you can have a label and call it dump. And what you are going to do is, and you move the hand and to the P1 plus P offset, and then you open your hand and you delay for 0.5 seconds. And then if the beta 7 is false, and you go to 10, 10. Otherwise, just return. So this is the sum 1000. So this is n. So this is 130 here, and so this is 130, and this is common. This is apostrophe. This comment, and then this is the main program. Okay, so this is the main program, and so here or this is here or 100 another program go sub dump. Okay, so go sub dump, and so you can either go using this label or and you can just go sub, and so this is a line this is a line number, and both will be okay. You understand, guys? You understand, guys? And you can either use the line number called sub line number. For example, this is 1000, or and you just use the label. Label here is a dump, and I can call the start dump. This one is okay, and this one is also okay. Questions so far? And then we talk about the for next. For next is a loop, as I said, and inductor robbers can help us do the tedious work. Tedious work means the repetitive tasks that human cannot, don't want to do. So this is 4, this is index, and 2 added number. Wait, next. So this is not easy to understand, but I'm going to give you one example. So here is one example is for M1 equals 1, this is the initial value M1, and to 10 is my end value of the M1. The step 2, I'm a step 2. If the step is left off, counter will increment in the unit of 1. But you can, if you do not have the step here, that means, so this loop will go to 1, 2, 3, 4 until 10. However, the step, you specify the step as 2, then it will go 1, 3, 5, 7, 9. You understand? And for this loop, what I want to do for each of these iteration, I want to move to the P safe, and then I move straightly in a straight line, a straight way, and to the P pick up, and then I next M1. So I'm going to do these two guys in multiple times. And for this case, and we totally have 1, 3, 5, 7, 9, 5 times. To move to the P safe and then move to the P peak. Any questions regarding this command? So whenever we see an example, we can learn these things much better. You guys agree? Otherwise, if I do not show you this example and just show you the preceding slide, it's not very easy to understand. And now it's very easy, right? Okay, these are 4 next commands. Questions so far? Questions so far? No question? No question. Then we talk about the palette. And in order to palletizing, you must define the palette. And otherwise, the industrial robots will not know what you are talking about. So this is a keyword. D5, DF, PLT, and they are keyword and pallet number and start point, end point B, end point A, end point B, a diagonal point, quantity A, quantity B, assignment direction. I hate this kind of explanation format. Okay. Now we take a look at the example. And here is one example. Define palette. I need to index this palette. This is my first palette. I have 1, 2, 3, 4. And I have 4 points. You understand, guys? Hidden.
Is a palette like a workspace for the robot to work within?
Yeah. So this palette.
Okay.
The grid, we call grid. How you arrange this is the items, blocks, work pieces, and then you want to handle and by using these industrial robots. I have 4 points: P1, P2, P3, P4, P5. And these are 4 points. Okay, so these are 4 points. And for this case, so this is my first point, P2. This is my second point, P3. And this is my P4. And so this is my P5. I want you guys to follow me closely. Based on my teaching experience, prior teaching experience, a lot of students they made a mistake because for our palette, we only have 2 by 2. So this is very, very misleading. But I need to have 4 points to define the range of this grid. And then I have 3 numbers. 3, the first number is a 3, means that in the first direction, I have 3 blocks, 3 items. Second number 5 means that in this direction, I have 5 blocks. So even though I have more, okay, I'm sorry, this is 3. So direction 2, you can see direction and zigzag. Zigzag, you know zigzag, right? You guys know zigzag? What is a zigzag? This way, this way, this way, this way, right? I'm serious. So zigzag means that, and for here you go for this line, first line, you go this way, right? For second line, and you go this way. This order matters. And then I go this way.